Okay, welcome back. Oh, sorry about that. I completely forgot I turned the mic on. Okay, what I want to continue with is, of course, types of electrical systems. Okay, and this is type of electrical systems A. I'm gonna put my teeth in. Okay. Now again, installation, buildings, and structures. That's your main foundation for the unit that you would be looking at. Okay. Identify the different types of electrical installations and systems. Okay. Now, outcomes from the session. At the end of the session, you should be able to know the different types of electrical installations required for emergency lighting and fire alarms, how to segregate cables for emergency supplies. Okay. Okay. Now, emergency lighting systems. Emergency lighting within any installation is essential. If it is very smoky or fumy, it is disorientating. Add to this darkness, it is very frightening. Emergency lighting level should be to the level of the light given off by a full moon minimum. Okay, that's how we calculate the value of the emergency lighting. It should be able to, as if you were dealing with a full moon. Every workplace shall have suitable and sufficient lighting, and also that suitable and sufficient emergency lighting shall be provided and maintained in any room in a circumstances in which persons at work are specially exposed to danger in the event of failure of artificial lighting. Emergency lighting design, implementation, and certification must be approved by the local fire prevention officer and/or local authority. Also bear in mind that the IEE regulations also lay down the foundations for emergency lighting, and those regulations you must comply with at all times. Okay? Sorry about that. These things will click on in the wrong time. Now again, emergency lighting continues, can be split into two parts. Escape lighting, this is short-term lighting. Standby lighting, this is long-term lighting and allows for some continuation of work. Basic requirements are to indicate clearly the escape route, to provide illumination along those routes to allow safe movement toward and through exits provided, to ensure fire alarm call points and firefighting equipment can be easily seen. Standby lighting should continue beyond the maximum time required to evacuate the building and allow for early reoccupation of the building. Okay, and again, let me just go in closer to this and pan back a bit to make sure we can get it fully in. Okay. And here we are showing you the emergency exit. An emergency lighting system must have an exit with a suitable sign, and when illuminated it must be of sufficient intensity and can be provided by two different power sources of electricity, so that the failure of one does not cause the light to fail. A completely independent operating system and be capable of operation on the failure of the supply of normal lighting. UK requirements also desire exit signs visible at all times. Escape route lighting, corridors and gangways are escape routes. Large open areas, offices, etc. should have an average illuminance of 1 lux. Signs either externally or internally lit at a height of 2 to 2.5 meters above floor level. Okay, now bear that in mind that this is relevant to the IEE regulations, and that will tell you for your period of time what the regulations stipulate, because you have to accommodate and allow for changes within these regulations. Okay, so always confirm and check with your on-site guide and your IEE regs. Okay. Maintain systems. We're going to this. Okay. Maintain systems. Okay, let me just pan back a bit and we can get it fully into view. Okay, there are two common ways in which emergency lights work: maintained and non-maintained. In a maintained system, the supply to the fitting is gained from the main supply and the light is permanently on. If the supply fails, the coil de-energizes and the battery is connected across the lights, which brings your lighting supply on. Okay, so it's backed up by 1, the AC supply, 2, it has a battery supplier supplied to it. So if your main source fails, then you have a battery backup which is designed to last so many hours. Okay. And here we have our non-maintained system. Let me just make sure we're going so you can see it's in view. Okay. Fan back a bit. Okay. Okay. In a non-maintained system, the emergency lighting is only on if the supply fails. The coil drops out and the battery is connected across the fittings. Okay. In a non-maintained system. In my view, the problem with the non-maintained system is that the battery charger, okay, over period of time, the batteries may deteriorate. So obviously, some maintenance may need to be maintained or applied to the emergency lighting. So it's worth bearing that in mind. That it's not just a case of installing your emergency lighting and leaving it or forgetting about it. It needs to be maintained one way or the other. Okay. And here we have a central battery. Let me just come back a bit, forward, then move forward, bring it into view. Okay, central battery system. Emergency lights can be supplied from a central battery source, which can also be maintained or non-maintained. Okay, now here we have a system contacted to de-energized, i.e. emergency lighting supplied from storage battery, mains failure, contact, transformer, rectify DC if required, charger, okay, storage batteries, and that will bring your light on when it drops out. Okay. A maintained system supply is fed via a mains failure contactor. When the mains fail, the contacts drop out and the contactor makes the supply is permanently provided. Okay. Okay. Central battery system. That's okay. We're just thinking that I've got to go out shortly. Central battery system. Okay. And here we have. Let me go back a bit to make sure we can get it into play. Okay. Yeah. In a non-maintained arrangement, the mains failure contactor drops out, a single contact, and the supply is connected to the emergency lights. Okay. Okay. Now again, it's worth drawing on some of these diagrams for yourselves. Okay. And again, comply with the IE regs at all times. Alright, let me see if I need to bring this up a bit. Do I? Yes, I think so, yeah. Fire alarm systems. Fire alarms are installed for two reasons: protection of property, protection of life. Fire alarm systems come in many shapes and sizes and depend on type of installation and the client's preferences. The cable usually used is MI/MS Pyro. MI has excellent heat resistant qualities. Fire alarms should not be protected by an RCD. Type P provides protection for property. Type L provides protection of life. Type M is manually operated systems. Now, bear in mind that it is very important that you comply with the IEE regulations in regards to fire alarm and systems, and you allow for any extension or any new modifications to the types available. It is your responsibility to check at all times. Fire alarms are usually split into zones, approximately 50 meters by 40 meters. No one should have to go more than 30 meters in a zone to discover the source of the fire. No one should have to go more than 30 meters in a zone to a manual call point. Sounders should produce a minimum of 65 decibels for more than 30 seconds. There should be a minimum of 2 sounders, one near the main control panel and one located elsewhere. Okay, let me just move in a little bit so you can see for yourself fully. Okay, and back out. Okay. Fire alarm panels. Now, what this shows you is how the fire alarm panels are located and situated. The supply has a dedicated local isolator. The batteries act as a backup when the main supply fails. The manual call points should be located on exit routes, each floor, landings, and staircases. No person should travel more than 30 meters to break a glass call point, not bare glasses. Okay. We're trying to be cynical here, but yeah, that's just a glass point, fire point, okay, of the glass unit. Okay, and all you can see here is you make local isolator red and lockable, okay, for your fire alarm systems, backed up by your battery, which then goes to your relevant zones. Okay. All right, smoke detectors. Smoke detectors, there are two types of smoke detectors. Now allow for any new modern types which may be coming on the market, but bear in mind these are the two types we are dealing with at this point in time. Ionization chamber type, this operates on the basis of a current flowing through the ionization chamber. Under normal conditions, ionized particles flow freely, and a small current flows. If smoke is present, the amount of current falls to a preset level, usually 10 milliamps, and the alarm is triggered. Okay. Okay, optical type. Optical detectors operate on the principle that light is scattered when smoke is present. When light falling on the light trap falls to a preset level, then the alarm is also triggered. Okay, to bear that in mind. And let me just pan back, make sure we can get it into full view. Okay, allowing you to zoom in if you wish. Okay. There are two types of heat detectors. Fixed temperature, this operates when a predetermined temperature has been set. Heat detectors are usually a simple bimetallic strip. This type is used where the temperature is fairly high and where there is little change in normal temperature. Rate of rise detectors, these can sense sudden change in temperature. Okay. And again, look for the new versions that may have come along since. Okay, so what you need to look at, I'll probably go into Google in a minute and see if there is a heat detectors, types of heat detectors, and bring that into view here as well. Fire alarm wiring. Okay, I'm going to make sure that we can see everything here. Okay, fire alarm wiring, you can see sounders, you can see your trigger points, end of line resistors. Most alarms use an open circuit system combined with some form of monitoring to check that there is no break in the circuit. Okay, these are your call points. Okay, again, remember when you're doing your fire alarms what the compliant regulations are, and keep an eye on that because sometimes it changes, so you must be up to date with your IEE regs. Maintenance checks. Now most people think that this is simple to do, and it is, but if you'd be surprised how many people actually don't do it, and that is one of the disturbing things of all. There are a number of maintenance checks that need to be applied: daily checks of indicator lamps, weekly tests of the panel key, switch and reset button, test alarm from the call point, check sounders and record results in logbook, make sure all sounders operate and are free from obstructions, quarterly test to check remedial actions and battery, operate a detector in each zone and check that sounders operate on a battery supply only. Annually repeat 1 and 2 above, check all detectors for correct operation. Every 2 to 3 years clean detectors. Replace batteries every 5 years. Now it's possible that this may have changed in regards to the type of batteries, because we have got some good batteries which has a rather longer life, or shorter one in some cases. So allow for any changes in regards to this matter and look at your IEE regs at all point in time. Okay. Automatic call systems. Okay. Automatic call systems can be set into place so that fire services can be automatically called. Direct private line, which is expensive, very reliable, but disliked by some fire brigades as they take time to test and advise about faults. BT operator discards against failure to receive an emergency call, but requires someone to be on duty. Direct or BT operated through alarms by carrier. Signal is sent to local exchange and fed to multiplex system, which then transfers it to relevant points. Okay. Central station operator uses the public telephone system to send coded signals to an automatically dialed control room. Okay. So that's your control automatic call systems in place. Now be aware of any others that might be available. Let me just try something here 1 second. Okay. Let me see if I can get into Google for you for a moment and look at heat detectors. Just for a moment, let me see if I could find anything on here. Okay, let's see what we can heat detection. Okay, let's see what we have. Commercial heat detectors. Let me have a look and see what that comes up with. Okay, nothing much. I'm not happy with that. Okay, not happy much. Okay, block. Never mind that. Okay, now let's see what else we can come up with. Okay, 2 main types of thermal detectors. I'm just looking to see if there's anything that we can see that's modern today that we can look at, and here you have a few. Okay, here we have some here. Okay, so you can see that there is a variation of types in today's world. Okay, there are 4 types of heat and smoke detectors. Let's have a look at that. I'm just going to bring that up. Let's see if we can see what it's on about. And what are the types of heat sensors? Okay, and I'm just trying to get this. Give me a second, couple of seconds to do this. So, but I don't want to stand this too long because this is something you can do for yourself. Okay, so I'm going to go back now and let's go up. Okay, go down a little bit more and see if we can find anything that gives us heat detection and overview. Nope, not. I'm looking for. Well, I'm looking for pictorial. Okay, let's have a look. Okay, yeah. And here's what your small checkers would look like. Okay, here is what you would be looking at. Okay. Okay. Variation of these, and that's it for now. Okay, thank you for your time. Have a good day, and bye bye for now. Talk to you soon.